In this example, an electron initially at rest is placed in an electric field of 5 times 10 to the power of 5 Newton per Coulomb directed to the rest. What is the acceleration of the electron due to electric field? And what speed will the electron acquire after moving a distance of 50 centimeters? So it said electric field directed toward west. So we have electric field like that. And an electron is placed in this field. So it means that due to this electric field, this electron experienced an electrical field to the right, because it's going to be opposite to the direction of the electric field. It says, what is the acceleration of the electron due to electric field? So due to this electric field, we're going to have acceleration, so m times a, and that's going to be Fe equals to E times Q equals to ma. What is the mass of the electron? It is 9.11 times 10 to the power of negative 31 kilograms. A, we don't know, we need to calculate it. E is given, which is 5 times 10 to the power of 5 Newton per Coulomb. And Q is the charge of the electron, which is 1.602 times 10 to the power of negative 19. So A will be 5 times 10 to the power of 5 times 1.602 times 10 to the power of negative 19. That's going to be 8.01 times 10 to the power of negative 14 divided by 9.11 times 10 to the power of negative 31. Minus 14, that's going to be 8.79 times 10 to the power of 16 meters per second square. So that's going to be the acceleration. And then on the second part it says, what speed will the electron acquire after moving a distance of 50 centimeters? So from kinematics we know final velocity squared equals to initial velocity squared plus 2 times acceleration times the displacement. Since in the beginning it was initially at rest, it means that the initial velocity was 0. So we're going to have Vf squared equals to 2AD, which means that final velocity equals to square root of 2AD, which is going to be 2 times 8.79 times 10 to the power of 16 times d, which is 0.5, which is going to be equal to 2.96 times 10 to the power of 8 meters per second.